All right, you guys, now we're going to talk about some special right triangles. You've probably seen these in geometry, but we want to make sure you have a quick little recap. Again, draw everything in here. So the first one is your 30, 60, 90 right triangle, right? 30, 60, 90 degrees right there. So you want to get that one down. Every 30, 60, 90 right triangle in the world has these following proportions. The smallest angle is across from the smallest side. This is x. X is across from 30. Okay? Across from the largest angle, the 90-degree angle, is 2x. And across from 60 is x times the root of 3. Those proportions will always be true for every single 30, 60, 90 triangle in the world. Another thing that I want you to notice is that a 30, 60, 90, actually I want you to write this down, a 30, 60, 90 triangle is basically half of an equilateral triangle, right? If I drew another one of these exact triangles right here, this is x, so this side is 2x, right? You see that we have 2x lengths on each side. It's a 30, 60, 90, two of them make an equilateral triangle. So that's just something that you should notice. I'm going to erase that, but just keep it in mind. Put two of those together. Ooh, this erasing is going to take a while. Put two of those together and you get an equilateral triangle. All right, so what do we do with the 30, 60, 90 in this situation? Well, what I'd like you to do is draw this little triangle here, number 7, okay? And we're going to use this as a reference, okay? So what I always do is I label my pieces. My hypotenuse is 2x, so I know this is 2x. I know across from the 30 degrees is x, so this is x, which means this right here is going to be x root 3, okay? So what I'm seeing now is, well, if 2x equals 16, what does x have to equal? Well, 8, right? If 2x equals 16, x has to equal 8. That's simple math. And well, if this side is, x root 3, if x equals 8, this side is 8 root 3, because it's just x times root 3. So in this case, x equals 8 root 3, and they're calling it y. Y equals 8 in this situation. So you just got to use a little bit of logic here. These are my favorites. So let's label this one, all right? So again, I'm looking down here. Across from the 30 should be x. So in this case, x equals 2. My hypotenuse should be 2x. So this is 2x right here, which means this is x root 3. All right? So if I know x is 2, 2x is 4. So in this case, u equals 4. Right? And if x is 2 and v is x root 3, well, x is 2, so that becomes 2 root 3, because this is literally x times root 3. Well, x was 2, so it's 2 times root 3. So those are my angles. U equals 4 and 2 root 3 equals v. Cool. Simple, easy. Hopefully you drew that. Hopefully that made sense. So that's how you use your special 30, 60, 90 triangle. Now, let's look at our 45, 45, 90 triangle. So go ahead and draw that one out. And you're noticing that we have two 45-degree angles and one 90-degree angle. Okay? And with this one, notice this angle and this angle are the same. So that means this side and this side are also the same. They are both have a length of x, and my hypotenuse has a length of x root 2. Okay? And just like before it was half of something, what is this one half of? Oh, how did I write it? I wrote a 45, 45, 90 triangle is half of a square. You put two 45, 45, 90s together and you get a square. And this is how you do it. Boom. Boom. Now I got two 45, 45, 90s and it became a square. So that's just another thing to notice. Okay? All right. So what do I do with these? Oh, these are fun. All right. So I'm looking at it here, and I know that my hypotenuse is x root 2. So in this case, A is x times root 2. And I know that this is an x. So if x equals 2 root 2, this is also an x. So it also equals 2 root 2. So B is equal to 2 root 2 because both of these sides are the same. They have the same measure. But now I got to take x times root 2 to get the hypotenuse. So if x is 2 root 2, and I have to multiply it, right? I got to take x times root 2. Well, I can do that. Well, root 2 times root 2 is 2. And then 2 times 2 is 4. That means A in this situation equals 4. Okay? So that one's not so bad. Let's go on over here to our last example. We have another 45, 45, 90. So that means this is x. That means this is x. And that means that 4 is the same as x times root 2. I believe that's right. Yeah. So if x times root 2, if x times root 2 is equal to 4, we want to figure out what is x. So basically, what number times root 2 is equal to 4? So I'm just going to solve this equation. 4 is x times root 2. So now I'm going to solve it for x. So I'm going to divide by root 2 on both sides. X equals, let's see if I can do this, 4 over square root of 2. Only thing is we can't keep a square root of 2. This is a simplifying thing. We can't keep square root of 2 on the bottom. So I'm going to multiply it by 1. But instead of calling it 1, I'm going to call it the square root of 2 over the square root of 2. Why do you think I did that? Well, because I know if I multiply the square root of 2 times itself, I'll ultimately get 2. So 4 times the square root of 2 is 4 root 2. And the square root of 2 times the square root of 2 is 2. And finally, I get down here and I say, oh, okay, well, 4 divided by 2 is 2 root 2. It's my final answer. So x equals 2 root 2. So x is 2 root 2. And this side, which is also x, is 2 root 2. So this is just a primer on this. Hopefully this looks familiar. You did some of this in geometry this year or a couple years ago, and we'll be working on it more. All right, you guys. Thanks.